So good morning to all of you. I am Akhilesh Dwivedi and today I'll discuss about mechanical properties of the matter. So in our first slide we will discuss about the states of the matter. So there basically we are studying the three states of the matter. So first one is a solid, another one is a liquid and third gas. So what is the solid? Solid is a state which have fixed shape and volume. Particles tightly packed and vibrate in a place. Okay, so it's known as a solid. Another one is a liquid. So liquid have a definite volume but takes the shape of its container. Particles closer together but can move around each other. It means particles are close to together but they can free to move and it have definite volume but take a shape as we are using a container. If we are using a glass, the liquid can take the shape like a glass. If we are using a bucket, then liquid can take a bucket. So solid example is a bricks, liquid example is a water, and similarly gas. Gas no definite shape, no any definite shape or volume. Particles widely spaced and move rapidly. So in gases there is no definite shape nor volume. Okay, particles widely spaced and move anywhere. So it's known as a gas. And one another state we will study the plasma. It is where the ionized gas come in that state. So in a solid to liquid conversion, solid to liquid. So when any object moves solid to liquid, any particles change solid to liquid, it's known as a melting. When any liquid particle convert in a solid, this process is known as a freezing. So if any solid convert into liquid, this process is known as a melting. And if any liquid converts in a solid, it is known as a freezing. Okay, so the simple example of solid to liquid and liquid to solid is a ice to water and water to ice. And similarly, the liquid to gas. So liquid to gas, if we are studying a conversion, liquid to gas, liquid particle change into the gas, this process is known as evaporation. And the due to the if we are start boiling any uh, water type water type object, then they start changing the form of the gas, then this process is known as evaporation. Similarly, the gas particles change in a form of a liquid, it is known as a condensation. In the foggy weather we can say the phenomena of condensation. Similarly, if the gas particle is directly changed in a solid, it is known as a deposition. And if solid particle is directly changed in a gas, this is known as a sublimation. Okay, so now we will move for next slide. So mechanical properties of the solid. If we are studying about mechanical properties, in our mind comes only two things. One is we have to studying in a mechanical property two types of body. One is a rigid, another one is a non-rigid. So, but basically, if we have any type of solid material, so we have to study the first term of a deformation. So what is the deformation? It means change in shape or size. If we are studying a change in a shape and size, it is known as a deformation. But how this change is possible? This change is possible due to the external force. So corresponding force is called a deforming force. If we are any external force applying to the particular material in which is responsible for the change in a material shape or size, it is known as a deforming force. It may cause changing in length, volume, or shape. In this process we can change length, volume, or shape. Okay, so now we will move for the next slide. So in this topic, we have to study two type of body in a solid. There is a rigid body, another one is a non-rigid. Rigid body is a totally rigid, totally the particles are hardly bounded to each other. Non-rigid body, there is a particle a little bit less bounded to each other. So in non-rigid, there is two types of material come. One is the elastic, another one is a plastic. So in a non-rigid body, what is the elastic material? Elastic material regain its original shape and size after the removing a deforming force. If we are applying any external force to change a shape, so it after removing the external force, after removing that force, it came at its original shape. It come at its original shape. It is known as elastic body. The example of elastic body is a spring, rubber, etc. So it is the elasticity. This phenomena is known as elasticity. Similarly, plasticity. So it doesn't get its original shape and size after the removing a deforming force. If we are removing a deforming force and it doesn't come its original shape, it is known as a plasticity, and this phenomena is also known as a plasticity. So example of plasticity is a bottle. We can see we removing, firstly we applying a force to deforming it. After we are removing, in this image we can see there is no uh, any external force, but it's not come its original shape. So after this we are studying the stress. Stress is a basically we can use the word for our tension in our mind, but in the physics we will study the stress. Stress is a restoring force per unit area. Whatever restoring force, what is the restoring force? Which is the force which applied to for the restored. It means firstly we stress the wire, after when it comes its original shape, that time the force applied force is known as a restoring force, in which restored. So this force is known as a restoring force. So formula of the restoring stress is a force per unit area, and the unit according to the force Newton, and the area meter square. So dimension from this unit m, l minus 1 and t minus 2. Similarly, the types of stress, there is a three types of stress. One is a longitudinal stress. Longitudinal stress, we can see this type of stress in the length, in the particular in straight line or the in a line. When we are studying this type of stress, then it's known as a longitudinal stress. And the long, in that form of definition we can describe the force per unit area in a particular straight line is known as a longitudinal stress. Similarly, volume stress formula, pressure, whatever pressure we are applying in a particular volume is known as a volume stress. And shearing stress formula, tangential force and pan area. So what is the tangential force? In the side corner, whatever we are applying a force in a particular tangential in this corner, this corner, this corner, and this corner, then it is known as a tangential force and pan area. So in a definition we can say it is the shearing stress is the ratio of the tangential force per unit area. Strength. So what is the strength? The strength is defined by the change its original dimension per unit original dimension. Whatever we are changing, observe after the applying a force and before the force. So if strength we can understood. So what is the formula? Change in original dimension, whatever change we observe after applying a force, and what the original dimension, and it is a unitless, so it is also dimensionless. Okay, so there is a, as we are studying three types of stress. Similarly, there is a three type of strain. One is a longitudinal strain, and another one is a volume strain, and third one is a shearing strain. So formula of longitudinal strain. So longitudinal strain is depend on the length. So long as I already told in a previous slide, this depend on the length. So original length and change in length. So it is a ratio between the change in length and original length. Then it's known as a longitudinal strain. Similarly, volume strain. So it's depend on the volume of the particular object or material. So it's a change in a volume. So it's a dV for the small volume and total volume. Whatever change we can observe, it's a dV and V though it's original volume. And shearing strain is a depend on the tan theta angles of that. So after these phenomena, studying these terms for basic for the elasticity and plasticity. That's why I start with that. Now it's come the main topic. First one is the Hooke's law. Hooke's law basically based on the elastic limit, which we can describe how we can describe the elasticity and elastic limit. So it states that within an elastic limit, the stress is directly proportional to the strain. So what the statement of the within a elastic limit, the stress in a elastic limit, there is a one limitation, elastic limit. It means it can come its original shape. So in this, the stress is in that time, the stress is directly proportional to the strain, and stress is a constant in strain. So that is the stress upon strain is equal to K. K is a constant. What is the constant? K is a modulus of elasticity. So SI unit of this Newton per meter square, CGS unit according to this dian centimeter square, and dimension m L minus 1 T minus 2. So modulus of elasticity, there we are introducing a new terms. One is the modulus. So it's a basically first one in a modulus we are studying a Young modulus. So Young modulus is defined by the Y. So what is the Y? Young modulus. It's a depend on what is the Young modulus? Young modulus is the ratio of longitudinal stress and longitudinal strain. So according to the longitudinal stress, we got formula in the previous slide, F upon A, and longitudinal strain L upon L. So F upon A upon L upon L. From this equation we get F into capital N and A into I. Bulk modulus denoted by capital B, and it is the ratio of volume stress and volume strain. Firstly, we will describe modulus. It's defined by the longitudinal, and its bulk modulus is defined by the volume stress and strain. Then it is the ratio of the volume stress and volume strain. So volume strain stress defined by dP and volume strain defined by dV upon V. So according to this equation, we will get V dP upon dV. So what is the bulk modulus? Formula for the bulk modulus B is equal to V dP upon dV. So after this, we will start to study about the modulus of rigidity shape eta. So modulus of rigidity is denoted by eta. So what is the modulus of rigidity? It's defined by the ratio of shearing stress and shearing strain. It is a ratio of the shearing stress and shearing strain. So shearing stress, formula of shearing stress, force per unit area, and shearing stress, as I already told, there is basically based on the angle. So according to this formula, we will get F upon A tan theta. And the eta is equal to F upon A tan theta. What is this? It's a modulus of rigidity. Now, compressibility. Compress, how the compress things. So it is the reciprocal of the bulk modulus. So what the bulk modulus? So it is the reciprocal of the bulk modulus, 1 upon bulk modulus, and whatever we will get at a bulk modulus, we will put at the denominator of this. So 1 upon V dP upon dV, and dV come is the upside denominator side, dV upon VdP. So there is a two strand we can read. There is a lateral strand and linear strand. So what is the lateral strand? Lateral strand is a ratio of change in dimension of original dimension perpendicular to the direction applied. Perpendicular direction applied. It changes we can observe changes in a perpendicular direction of the applied force. So formula d upon d. And similarly, linear strain, we can observe changes in the original dimension along the direction of the force. Then there is a formula L upon L, where the uh, original dimension and applied force. So there is a d upon d and L upon L, where d and capital L shows the original shape and dimension, and small l and d shows the changes in that. Now, the next topic is a Poisson ratio. So what is the Poisson ratio? The Poisson ratio is the ratio of a lateral strain and linear strain. So Poisson ratio is defined by sigma. Sigma. So it is the ratio of the lateral strain upon linear strain. So lateral strain upon the linear strain. This is the formula. Lateral strain d upon d and linear strain L upon small l upon capital L. So according to this formula, we will get dl upon di. So there is a graph of the stress strain curve. It's a very important graph. In a x-axis, we are going to describe a strain. In a y-axis, we will going to describe a stress. So there is a, firstly, we are trying to show the elastic region from starting from the origin 0, 0, sorry, origin 0, 0. So there is a elasticity, there is a shows the elasticity this point to this point, and there is a yield point a point last point where the object shows the elasticity, so it's known as a yield point. And there is a plastic region is a, after yield point the region started is known as a plastic region. It doesn't come its original shape, and we are applying a ultimate stress and the fracture point. This is a fracture point, then we that completely destroy material. Then this graph shows is a stress strain graph. So there is a elastic region, it's known as the yield point, and there is a plastic region. And when we are applying a ultimate force and ultimate stress in this point EF. Here, after this, we are going to discuss about the determination of a Young modulus of the material of the wire. There is a Young modulus of the material of the wire. There is a reference wire. There is an experimental wire. So there is a meter scale we are mentioned, and there is a vernier scale, meter scale and vernier scale. So and this is experimental. What experimental wire? There is a only one bob we are using. There is a three bob. So it is the, in a Young modulus we are describing the longitudinal. It is a, we are describing by a ratio between the longitudinal stress and longitudinal strain. So according to this, FA upon L by L. So F by A upon L by L. So F, according to this, FL upon AL. After this, we know the gravity F is equal to mg. So according to the Newton's second law. So then Y is equal to mg L upon area of this. So pi r square L. So according to the what will be the modulus of the material of the wire? Y is equal to mgl upon pi r square L. Thank you.